Alright, today we're going to be doing AP Calculus AB, section 3.3, and I'll be guiding you through how to do increasing and decreasing functions on the first derivative test. Alright, so first we're going to do determining function features, where we determine all x values for which the graph of f has a local minimum on the open interval -9 to 9. So this graph, it's an open interval, and what we're asked to do here is determine all the x values for which this graph has a local minimum. And if you remember, local minimums are just points such as here or here where the slope changes and you get a minimum. So looking at this graph, it's clear that there's a point local minimum at x equals -6, and tracing it, there's a local minimum at x equals 1, and then there aren't any more. So x equals -6 and x equals 1. Those would be your local minimums. Alright, here it's asking you to determine the absolute minimum, so the absolute lowest value on the whole interval from -9 to 9. So this is an open interval, and if you trace the graph from its beginning to its end, you're going to see that the lowest point is around here, but this is an open interval, so x equals 9 doesn't exist, so it has no absolute minimum value, meaning that it's no solution. Alright, here it's asking determining all intervals on which the graph of f is decreasing on the closed interval -9 to 9. So now these points, they're closed, and it's asking where is f decreasing. So f is decreasing, you're going down, down, down. This is where it's going down. It goes up here, it's increasing, so this is not what we're looking for. Then it goes down again. So from -9 to -1, you're going to be decreasing. And then it's going up here, and then from 6 to 9, you're going to be decreasing. Alright, now determine the absolute minimum value. On this time it's a closed interval, so these points exist, but if you trace the graph, you're going to see that the lowest minimum value is right here at x equals 5. So at x equals 5, the value f is -3. So your answer would be -3. Now determine all intervals where f is decreasing again. So where f is going down, from right here to right here it's going down. Right here to right here, it's going increasing. From here to here, decreasing again. And then here to here it's increasing. So it's decreasing from -9 to -4. And it's decreasing from x equals 1 to x equals 5. Okay, so now we're gonna use the first derivative from the graph of f to determine where f prime of x is greater than or equal to 0 and where f of x is greater than or equal to 0 on the interval. So this is an open interval, but remember that f prime of x is greater than or equal to 0 whenever the function is increasing, and f of x is just greater than 0 whenever it's over 0. So we're looking for two things: when it's increasing and when it's over 0. So first it's going down here, so we're not looking for that because it's decreasing. But here it increases, but it is below 0, so we're not looking for that either. But from -1 to about -3, you see that the function is increasing and um, it is over 0. So that is one interval where f prime of x is over 0 and f of x is over 0. So from negative 1 to 3. And if you look again, it's decreasing from here to here, and then increasing, and then from here to here, it is increasing, but it's an open interval. Oh yeah, so you would just say from 8 to 9, it's also increasing and it's over 0. And you're using parentheses to show that it's an open interval. Okay, so determine all intervals on the open interval where f prime of x is less than or equal to 0, which means that the function would be decreasing. So we're going to locate all intervals where the function f is decreasing. So from here to here, it's clear that the function is decreasing. So from negative 7 to negative 4, and then it's increasing from here to about 0, and then it decreases again from x equals 0 to x equals 3, and then it increases for the rest of the function. Okay, given this graph, determine where f prime of x is greater than or equal to 0, which means that it's increasing, and where f of x is greater than or equal to 0, which is where it's over to 0. So we just did something like this. So it's increasing and greater than 0 from negative 9 to negative 5. And it's decreasing all the way here. And here it's under 0. So we just skip to here. And from about x equals 4 to x equals 5, it is decreasing and over 0 again. Alright, now working further with the first derivative from the graph of f, we're going to see where f prime of x changes its sign. So on this interval, it goes like this, right? So what it means when it says f prime of x changes sign, it just means where f prime of x goes from negative to positive or positive to negative. And remember, it's positive whenever f of x is increasing, and it's negative whenever f of x is decreasing. So from here, you can see it's decreasing, decreasing, decreasing all the way to negative 1 at x equals negative 1, and it starts increasing again. So at x equals negative 1, it changes its direction, or it goes from decreasing to increasing. And then it goes from increasing all the way to x equals 3, right? And then from increasing it goes to decreasing again. So at x equals 3, it changes sign. And then decreasing from 3 to 5, and then at 5 it goes to increasing again. So at x equals 5, it's going to be changing sign again. Alright, again, looking at where it changes sign, we're going to see where it goes from increasing to decreasing. So at x equals negative 6, and then trace it, trace it, trace it. This is decreasing all the way to 0, where it goes to increasing, and then increasing, increasing, increasing for the rest of the graph. So it'd be negative 6 and 0. Now we're going to determine values of x where f prime of x equals 0, but f prime does not change. So remember, f prime of x equals 0 just means that the slope is 0, or that the slope is horizontal. So we're looking for a horizontal slope in addition to whenever f of x does not change sign, so it's not going to go from increasing to decreasing. So our first thing that we can do is to locate everywhere where f prime of x does equal 0. So whenever the slope is horizontal, and that would be right here, that would be right here, that would be right here, and that would be right there. So we have 4 x coordinates where f of x is equal to 0, where the slope is 0, because this line is horizontal, right? But 3 of these 4, increasing, decreasing, decreasing, increasing, and then increasing, decreasing, 3 of those 4 points, they do change sign. So the only point that doesn't change sign is right here at x equals negative 2. It doesn't change sign. Okay, now we're going to be looking at a differentiable function of f and comparing its derivative values graphically. So in this problem, they give us f on the open interval negative 9 to 9, and they give us statements. They give us statements right here, and we have to determine which one is true. So f prime of negative 7, f prime of negative 4, and f prime of 4. So looking here, this they're asking basically like which one is greatest or least or in the middle. So looking at the graph, we can see at x equals negative 4, you're going to have a horizontal slope. So you're going to have a slope of 0. F prime of negative 4 would be 0. Right, and at negative 7, right here, the function is increasing, so you're going to have a positive slope. So now we know that f prime of negative 7 is greater than f prime of negative 4. And now looking at x equals 4, you're going to see that's decreasing. So it's a negative value at x equals 4 for f prime. And then negative 4 is just 0. And then negative 7 is an increasing value. Because, negative 7 is a positive value because it's increasing. So our greatest is going to be f of negative 7, f prime of negative 7. Our middle value is going to be x equals negative 4, f prime negative 4, and our least value is going to be f of 4, f prime of 4. So that matches up with that statement. Okay, now we have a new function. So let's look at f prime of negative 4. We're going to see that's decreasing. So f prime of negative 4 is a negative value. F prime of 4 is 0. This slope is 0. And f prime of 6 is increasing. So our greatest is going to be f prime of 6 followed by f prime of 4, and then last place it's going to be f prime negative 4. And that matches up with this one. Okay, now we have this function, f prime of negative 3. Let's look at that. At negative 3, the function is decreasing. So f prime of negative 3 is a negative value. Then at 0, you have a horizontal tangent line. So f prime of 0 is just 0. And then f prime of 6 is increasing. So your greatest is going to be f prime of 6, followed by f prime of 0, and then last place is going to be f prime of negative 3, which matches up with this statement. Okay, now we're given a function f, and we have to determine where it's increasing or decreasing. So we're given f of x equals negative 4, negative x, f of x equals negative x to the 4th minus 4x to the 3rd, and we have to find where f prime is decreasing. So remember that f is decreasing wherever f prime is negative, which means that f prime is decreasing wherever f double prime is negative. So we have to find for f double prime. So first doing f prime, you get x equals negative 4 x to the third minus 12 x to the second. And then doing f double prime of x, you get negative 12 x to the second minus 24 x to the just x. So then solving that for 0, you can take out a negative 12x, so you'd just be left with x plus 2. So x would be 0 here at x equals 0 and x equals negative 2. So now we can plug in right here f prime to find the increasing and decreasing. So we would plug into f double prime using our x values. So negative 2 and 0. Now if we plug in negative 2 or 0 to this function f double prime of x, we would get 0, which is why it's a critical point. But if we plug in values, say less than negative 2, or in between negative 2 and 0, or over 0, we would be able to find where f prime is decreasing or increasing. So if you plug in a number such as negative 3 to this function, you'd get a negative value, which means that f prime is decreasing. And then from negative 2 to 0, if you plug in a value such as negative 1, you would get a positive value, which means that it's increasing, and that's not what we're looking for. And then from 0 onwards, if you plug in a value, you get negative, which means that it's decreasing. So from negative infinity to negative 2, the function is decreasing, f prime is decreasing. And then from 0 and above to infinity, it's also decreasing. So from negative infinity to negative 2, and from 0 to infinity. Okay, now we're given f of x equals x to the fourth minus 16x to the third, and now we're looking for where f is increasing. So now we only have to deal with f prime. So f of x equals x to the fourth minus 16x to the third, and we only have to find x prime, so f prime. So f prime equals 4x to the third minus 16 times 3 is 48, and then x squared. So here, if you take out a 4 and x squared, you'd be left with x minus 12. And here x would be 0 and 12. So now we create the same thing where now we use f prime and x. And we're going to plug in values less than 0, between 0 and 12, and over 0. Now if you plug in a value that is less than 0, you'd get a negative. And then between 0 and 12, it's also negative. And then from 12 onward, it's positive, which means that it's decreasing, decreasing. So from negative infinity to 12 is decreasing, and then from 12 to infinity is increasing. F is increasing, which is what we're looking for. Okay, now we're again looking for where f is increasing. So first we find f prime. So let's write down x equals negative 4 x, no, negative x to the fourth minus 12 x to the third minus 36 x squared. So f prime of x would be equal to negative 4 x third minus 36 x to the second minus 36 times 2, whatever that is, 72 x. solving that for 0, you can take out an x from everything, and then you're left with negative 4x squared minus 36x minus 72. So now if you solve for x, you get x equals 0 and negative 3 and negative 6. So now we can find where f prime is increasing using those values and f prime. So negative 6, negative 3, and 0. So from infinity to negative 6, if you plug in a value like negative 7, it would be positive. And then from here to here, if you plug in a value like negative 5, it would be negative. From here to here, if you plug in a value like negative 2, it would be positive again. And then after 0, it would be negative. So increasing, decreasing, increasing, and decreasing. So negative infinity to negative 6, and negative 3 to 0 is where it's increasing. Okay, now we're given a function f prime of x, and we have to determine all intervals on which f is decreasing. So here they already give us f prime of x, which is negative x to the third minus 12x to the second minus 27x. And see, now with this we can just find the zeros of this function and then plug in values to see where it's increasing or decreasing. So to just solve for 0, we can just take out a negative x, and then you're left with x squared plus 12x plus 27. And solving for 0, you'd get 9 and 3. You can use 9 and 3. So fully factoring it out, it looked like x plus 9 and x plus 3. So x would be 0, negative 9, and negative 3. And plugging in those numbers into f prime of x, you would get you would be able to find where f is increasing or decreasing. So negative 9, negative 3, and 0. So plugging in a value less than negative 9, you'd get a positive value. Then from negative 9 to negative 3, if you plug in something like negative 6, you'd get a negative value. Then from here to here, if you plug in something like negative 2, you get positive again. And then after 0, it would be negative. So increasing, decreasing, increasing, decreasing. And we're looking for where f is decreasing. So it'd be right here and right here, or from negative 9 to negative 3, and from 0 to infinity. Okay, now we're given f prime of x. Okay, for this question, they give us f prime of x equals negative x to the third plus 18x squared minus 81x. And here, instead of finding where f is increasing, we're finding where f prime is increasing. So to find where f prime is increasing, we have to see where f double prime is positive or negative. So f double prime, negative 3x squared plus 36x minus 81. And solving for the zeros here, you get x equals 3 and x equals 9. So now we can draw this f prime and f double prime using x, and it'd be 3 and 9. And plugging in values before 3, you'd get negative value into f of double prime, and then plugging in values from 3 to 9, you'd get positive, and then after 9 you'd get negative, so decreasing, increasing, and decreasing. So f prime is increasing here from 3 to 9. And now they give us f prime of x equals x to the third minus 30x. And it's looking for where f prime is decreasing, so we have to see where f double prime is negative. And looking for f double prime, you do the derivative of that, which is 3x squared minus 30. And solving for 0, if you take out a 3, you would just get x squared minus 10. And x squared minus 10, solving that for 0, would be x squared equals 10, or square root that and square root that, x equals plus minus square root of 10. So now we can use that to find where f prime is decreasing. At negative root 10 and at positive root 10. In a value that is less than root 10, you would get a positive value. And then plugging a value such as 0, you get a negative value. And then plugging a value such as, I don't know, like 100, you get a positive. So increasing and then decreasing and then increasing. So we're looking for where f prime is decreasing. So it'd be from negative root 10 to positive root 10. Negative square root of 10 to positive square root of 10. Okay, now we're given a function on a closed interval, and we have to determine the absolute min or max. And for this one, we're given f of x, and we have to determine the absolute max of it. So f of x equals x to the fourth minus 20, x to the third plus 28, x squared plus 1. So now to remember to find an absolute max or min, we have to first find the local extrema, and when we're given a closed interval, we can use those endpoints of the interval as well to determine if the function has an absolute max or min at those points. So f prime of x first equals 4x to the third minus 60 x squared plus 28 times 2, which is 56. 56 x. Okay, now if you solve for 0 here, you would get x equals 0, 1, and 14. But 14 is not a number that we're interested in on our interval, so we can just ignore that. So now we have these values, which are our critical points, and we also have the closed interval value, so plugging in f of negative 1 and then plugging in f of 0, f of 1, and f of 2. And remember, we're not plugging in to our f prime of x function because we're actually trying to determine the maximum value of f, so we're plugging into f. So f of negative 1 is 50, f of 0 is 1, f of 1 is 10, and f of 2 is negative 31. So we're looking for the absolute maximum value, and that's 50. So we would write 50. Okay, now we have to determine another maximum value, and they give us f of x. So f of x equals x to the third minus 9x squared plus 27x minus 2. Right, so f prime of x would be equal to x squared, 3x squared, minus 18x plus 27. Okay, and if you solve for x here, the only x you would get is x equals 3. And that's on our interval, so we can check that point. So f of 1, f of 3, and f of 4 would be the points that we're checking. If you plug in f of 1, you'd get 17. Plugging in f of 3, you'd get 25, and f of 4, 26. So 17, 25, 26. And looking for absolute max is 26, and that's our value. Okay, now we're doing the same thing, determining absolute max or min on the interval with the function f. So f of x equals x to the third plus 6x squared plus 6. And this is our interval, but first we have to find the derivative f prime, so it'd be 3x squared plus 18, no, plus plus uh plus 12, plus 12x. And then if you take out a 3x, you'd be left with x plus 4. So it'd be, your values here would be x equals 0 and x equals negative 4, which both fall on our interval, so we can use those to check our max or min. So f of negative 5, f of negative 4, f of 0, and f of 1. Negative 5 into our f of x function, we get 31. Then into negative 4 into f, we get 38. 0, it'd be 6, and 1 would be 13. So here it's looking for the absolute max, and that would be 38. Okay, now they give us f of x equals x to the third minus 12x plus 6. And now we're looking for an absolute minimum, and our interval is negative 3 to 3. So f prime of x would equal 3x squared minus 12, and if you just take out like 4, you get x squared minus, no, if you take out 3, sorry, you'd get x squared minus 4. And that's just x plus 2 and x minus 2. So our zeros on this function is negative 2 and 2. So plugging in negative 3 into f, negative 2 into f, 2 into f, and 3 into f. Okay, and if you plug in f of negative 3, you'd get 15. Plugging in negative 2 would give you 22. Plugging in 2 would give you negative 10. And 3 would give you negative 3. So our absolute min on this interval would be, our absolute minimum value would be negative 10. Okay, now we are given a function f of x, and we have to determine uh, stuff like its relative min or relative max, or where it's increasing or decreasing using the first derivative. So we're given f of x equals negative x to the third plus 9x squared plus 18. And this question specifically asks for relative minima, and we can discuss what that means in a second, but first let's do the f prime of x, where f prime of x equals negative 3x squared plus 18x. And if you take out a negative 3x, you'd get x minus 6. So x equals 0 and x equals 6. So plugging that here, we can do the same thing as we did earlier, where we found where where f or f prime was increasing or decreasing. The same chart, 0 and 6. Okay, and doing the same thing as earlier, if you plug in a value less than 0, you get a negative. You plug in a value between 0 and 6, you get positive. And then after 6, it'd be negative. So decreasing into increasing into decreasing. And we're looking for the relative min. So just looking at this graph, if a graph goes from decreasing, say, if a graph goes from decreasing and then goes from increasing, there'd be a min here. And if a graph goes from, say, increasing to decreasing, there'd be a max. And in this, since we're looking for a min, we're looking for decreasing to increasing. And here, increasing and decreasing, at x equals 0, there is a relative min at x equals 0. And now, same thing, we're still looking for a relative min, but this time it's f of x equals 2x to the fourth plus 24x to the third. Okay, so f prime of x would be equal to 8x to the third plus 24 times 3, which is 72 x to the second. And if you take out 8x, then no, if you take out 8x squared, then you'd be left with x plus 9. So So here our x would be 0 and negative 9. So we can do the same things earlier, where we graph f prime, and x. Negative 9 and 0. Okay, and if you plug in a value here, you'd get negative. And plugging in values here and here, you get positive. So go from decreasing to increasing. And that's a relative min right there. And remember, if they ask you for a relative max, then it would just look like this instead of like this. So relative min at x equals negative 9. Alright, thank you for joining me doing 3.3 from the textbook, talking about increasing and decreasing functions, as well as the first derivative test. Thank you.